Greetings everyone. I want to go over the homework from undamped springs. So I remind you, we are in the equation that we're looking at is this one. So if Ft is 0, then we speak of a free movement of a spring, which, by the way, I should introduce you. I mentioned it also in other videos. This is the harmonic movement. This is a harmonic, harmonic movement. That springs, the way that springs make an object move, is called a harmonic movement. Okay, so if F is 0, then we have a free harmonic movement, otherwise we have a forced one. And this is undamped because there is no y prime term. Okay, so undamped means no y prime. Because the dampening depends on the velocity. We have seen this also, this is, at least in this model. Okay. Good. So we number 11. This one will be a free one. No, it isn't. No, the free ones are simple, so I'm not going to do them. So I do two forced ones. A unit mass hangs in equilibrium from a spring with constant 1/16. Starting at t equals 0, a force of 3 sine t is applied to the mass. Find its displacement. Okay. So we need to discuss the setup, everything. And there are a couple of things that in the formula that we still have determined, these things, right? Now, I remind you of a formula here. A very important relationship is that k over m is equal to g over s. And remember, s is for what I call the distance between, it's even if I make a picture, it's this distance. So how much the spring stretches when you hang something on this hang the particular object on it. Of course, it depends on the weight of the object. Okay, so but this is a relationship here, and so sometimes they are giving you this one. G, of course, is the universal constant, so there's no problem here. Sometimes they give you this, and this is what happens here because they tell us that k is 1/16, so k is 1/16. But if we want to use this part of the formula, we also need to use m, which is the mass, and they tell us the unit mass, which means mass is 1. M is 1. Okay, so this constant here becomes 1/16/1, so 1/16, y equals, and then what is the a force? It's the forcing function is 2 sine t. Okay, so this is the equation that we're trying to solve. And there are some initial conditions. We will discuss them when we get to it. But let's start with this one. Well, it is second order differential equation with constant coefficients, but non-homogeneous. So we know the step 1 would be the complementary homogeneous solution, homogeneous equation. So that becomes y double prime plus 1/16 y is 0. So the characteristic equation, because we have constant constants, that's why we can do that. T squared plus 1/16 is 0. That means that t squared is equal to -16, so t is equal to plus or minus I radical 16, so plus or minus 4i. Okay? We know that this always comes out to be something of this form, right? And so we know, therefore, that the general homogeneous solution is, well, the 4 here, that's the omega. So we're going to have a cosine or a sine, cosine 4t. That's one of the fundamental solutions, and the other one is sine 4t, and they have just some constants. Okay. Step 2. In this particular case, so this is a method that I told you is basically a section we skipped, and because we are doing it now, basically. And so in there we were told that if you have a constant coefficients, linear homogeneous or second order equation. If the forcing function is a sine or a cosine or even a linear combination of these two, then the general solution, a particular solution is of the form, I'm going to use the same A and B, but this is an A and B that I'm going to use temporarily because I'm going to determine. It's not the A and B over there yet. So the A cosine. Now what? Well, it's now the argument that we have here that we have to use. Okay, don't confuse with this 4t here. It's this t. Okay, so. Okay, and what we need to do is then the method of undetermined coefficients. So we have to find y prime. Y prime is a or minus a sine t plus b cosine t, and y double prime is then minus a cosine t minus b sine t. Okay, very simple. You have to just keep your head straight that you don't get the signs wrong. So we have y double prime plus 116y is 0. I could perhaps write it the other way. So no, let me write it that way. So it's minus a cosine t minus b sine t plus 1 over 16 a cosine t plus 1 over 16 b sine t. And that has to be equal to, what was it? 2 sine t. 2 sine t. Okay? And how's the method of comparing coefficient work? It's different. If it's polynomials, we compare the powers of t. If it's sines and cosines of the same angle, right? Then we compare the sine and the cosine. So let's see what is the cosine. The cosine has a minus a and a 1/16, so it is 1 minus 1/16 a, and the cosine over here is 0. Right? There's no cosine. It could be there, but it is not there. And for sine, well, it's the same thing. It's sine t. It's a minus. Oh, I did this wrong, right? Yeah. This is a minus 1 and a plus 6. It doesn't make a difference because it's equal to 0, but I should do it correctly. That was a cosine. So for the sine. So the sine, I'll do it in green. That is a minus b plus 1/16 b. So I'm taking the b out, but that is now equal to the 2 that we have here for the sine. So here, so we have seen that this follows that a is 0, right? Now here we have to work it out. Multiply everything with 16, so we get minus 16 plus 1. B is 32. So 60 minus 1, that is minus 15. B is 32, so B is minus 32 over 15. Okay, so our general solution is, or a particular solution, let me write first that one up, is the A is 0, so it's minus 32 over 15 sine t. So what is our general solution now? Well, we have this, this fellow here, right? Oh, whoa, what was I doing here? T squared is minus 1 over this thing. Everything is 1 over this thing. Jesus, t over 4, right? And this is a sine t over 4. I'm sorry. It's 1 over 16 here. I wrote it down correctly here, but then I all of a sudden switched it over. So, okay, so this is plus or minus 1/4 I. So omega is 1/4 here, the frequency. Then what we call this is called the natural frequency of the spring, meaning what happens if there's just a weight hanging on it, nothing else, no other forces, and gravity, of course. So that is the natural frequency. So okay, so now we have to write this in terms of this natural. So what I'm writing down, I'm sorry. Let me write down now. As the principle always, it's the particular solution plus the general homogeneous solution, right? Sorry. The particular solution was minus 32 over 15 sine t, and the homogeneous solution was a times cosine t over 4 plus b times sine t over 4. Okay, that is y. So this is how the general solution looks like. But there is initial conditions. What happens? Well, starting at t at 0, it is in equilibrium. So if t is 0, then y is 0. It is in equilibrium, and do we give and nothing, no extra velocity is given to. You could have given a push, but we don't. So y prime is also 0. Okay, so this means that if I plug this 0 on the left hand side and t equals 0, the signs disappear, and the only term that's left is a. So we see that 0 is a, and now of course to find b I have to use this initial condition, so I need the derivative. Y prime is derivative of sine is minus cosine, so that these cancel sines, and so get cosine t here. Derivative there would be a over 4 sine t over 4, and there's a minus sign there, right? And then derivative here will be p over 4 cosine t over 4. Yes, right? Yes. So the derivative of cosine is minus sign. Yeah, okay. Okay, now we plug in t equals 0. Of course, then this sign is disappeared. This guy is not there, but these two guys do survive. So we get this one plus b over 4, and that is 0. So we see that b over 4 is equal to minus 32/15, and so b is equal to minus 128 over 15. So our solution is y is equal to minus 32 over 15 sine t minus 128 over 15 sine t over 4. And I just want to double check that this is didn't make any silly mistakes. Well, it seems I made a sign mistake. Did I? Wait, let me see here. 11, right? The t over 4 should be a positive constant here. Did I make a mistake here? A and b. We're taking derivatives, right? So derivative of cosine is minus sign. This is a plus. And the derivative of sine, the derivative of sine is cosine, so this remains a negative sign. Oh, I'm sorry. So this is still a negative sign, so this becomes a positive sign, so this is a positive sign, so this is a positive sign. And now it's correct.